In this video, we're going to look at some more about buffer solutions. So in an earlier video, we discussed that buffer solutions are formed from the combination of a weak acid and an ionic compound containing the conjugate base of that weak acid. So this solution would fit the bill. And what we find is that if we make this solution in the lab and go to measure the pH, it has a pH of about 3.3. If we mix this buffer solution of acetic acid and potassium acetate, we find that its pH is about 4.7. If we mix a solution of hypochlorous acid and sodium perchlorate, we find that we get a pH of about 7.5. And it turns out that there's a rule for finding the pH of these mixtures as long as there are equal molarities of the acid and the conjugate base present in the solution. As long as these are equal, we find that there is a rule which is that the pH is equal to a quantity called the pKa. Now remember that this lowercase p is just a math symbol that always means take the negative log of the thing behind it. So if we say pH, that was the negative log of the hydrogen ion concentration. When we say pKa, we mean take the negative log of the Ka. So we're going to define the pKa as the negative log of the Ka value. All right. Now, again, this is a rule that applies only in one specific situation. The pH is equal to the pKa only if you have equal concentrations of the acid and the conjugate base. Any other situation, you're going to have to work a rice problem in order to figure out what the pH is, all right? But for this one situation where you have equal molarities of both the acid and the conjugate base, this rule is going to apply. So we can do an example just to double check ourselves. So we can look at the acetic acid plus potassium acetate solution. And again, let's say we had 0.20 molar acetic acid and a concentration in the same solution of potassium acetate of 0.20 molar. That now we have equal concentrations in solution, so we can find the pH of this solution by finding the pKa, which is the negative log of the Ka value. And very likely by now, you've memorized that the Ka of acetic acid is 1.8 times 10 to the negative 5. So if we take the negative log of 1.8 times 10 to the negative 5, we get our calculator, and we try that out. Okay. Negative log 1.8 times 10 to the minus 5, and we get 4.7. So that means that the pH in this situation is going to be equal to this pKa, the negative log of the Ka, of 4.7. This saves us a lot of work in terms of working a rice problem. Although the rice problem isn't that difficult, this saves us some time if we just know this general rule. We're also going to see this come up in titration curves, which we will discuss at a later date. So whenever we are faced with a situation involving a buffer, remember, is always going to be an acid and the conjugate base. If they are in equal molarities, we can find this pH value, which otherwise we would have to do a rice table or go in the lab. But we can shortcut this by using this equation that the pH is equal to the pKa if the acid and conjugate base are present in equal concentrations. Thanks, everyone.